In this video, we're going to be looking at graphing exponential functions from equations. And fortunately for us, this is extremely similar to graphing them if you know the initial value and the base, because all we're doing is using that same technique, except first we have to use the equation to find the initial value and the base. So let's look at our first equation to graph, y equals 2 times 3 to the x power. And the first thing we need to do is identify the initial value and the base from this equation. And so it turns out that our initial value is 2, and that our base, or our growth factor, is going to be 3. Now that I have that information, I can use those points, or use those values to plot points on the graph. So first, our initial value, this is going to be our y-intercept, which is 2. And then we know we have a growth factor of 3. So if we start at 2 and we have our x value go up by 1, we have to take that initial value and multiply by 3. 2 times 3 would be 6, and that would be my next y value. So I can see my y value went from 2 to 6. 2 times 3 is 6. And then if I go over one more point from there, I would have to take my new y value, 6, and multiply it by 3. Well, 6 times 3 is 18. And so here I can see that pattern of the exponential function. Y times 3 would be 6, times 3 again would be 18, so on and so forth. And when I connect those points with my characteristic banana-shaped graph, I end up with this, and have now graphed the exponential function. Next, let's graph the equation y equals negative 3 times 4 to the x. Just as before, I need to look at the equation and find what my initial value and base will be. So in this case, the initial value will be negative 3, and the base will be 4. To plot these, I first plot the initial value as the y-intercept, because that's what it is. So that would be negative 3. Now to find my next y value, the y value when x is equal to 1, I take negative 3 and multiply it by the base, which is 4, meaning that when x is 1, my y value will be negative 12. Now I can do this again to find the y value when x equals 2 by taking the y value at 1 and multiplying it by 4. So negative 12 times 4 would be negative 48, which means that that point for 2 is way, way, way down here. And you can see I've already plotted it for convenience sake. But let's come back up here with the understanding that now I've plotted these points, and if I connect them, what I will see is my nice, neat exponential function, just as I was wanting. Finally, let's look at graphing the equation y equals 20 times 1/2 to the x power. So for this one, I again want to find my initial value and base from the equation. So my initial value would be 20, and my base is 1/2. Now remember, when you have a base that is less than 1, then we are going to have the initial value get smaller and smaller as we go along the x-axis. And so we can do these just as we've done before. Let's plot the initial value of 20. When x is equal to 1, to find the y value, I have to take that 20 that I started with and multiply it by 1/2. Now remember, if you are multiplying by 1 over some number, that is the same as dividing by the denominator, that is the bottom half of that fraction. So 20 times 1/2 is the same as 20 divided by 2, which is 10. So at the point, or when x is 1, my y value will be 10. To find the y value when x is 2, I would take that 10 and again multiply by 1/2, which will give me 5. And now that I have those points, I can draw my typical exponential function curve through those, and I see this nice, neat exponential function that looks and behaves exactly like we would expect.